Now, after this, these characteristics, let us talk about chemical equations. So, what are chemical equations? It is nothing but the representation of chemical reaction in terms of symbolic form. Like if I am writing iron reacts with copper sulfate, then if I take the symbol of iron as Fe and take the symbol of copper sulfate as CuSO4 and write the reaction by using the symbol, we call it as chemical equation. So, when we have any chemical reaction in the form of word root, then we write it in symbolic representation and finally we will get the equation form. We call it as chemical equation. So, we can say that writing any chemical reaction in the form of symbol, in the form of formula, we call it as chemical equation. The substances which combine or react, as we have already discussed, are called reactant and they are always written on the left hand side. Similarly, the new substance which has been formed during the reaction, we call it as product and it is always written on the right hand side. And a chemical equation is always the shorthand representation in the form of symbols is called chemical equation. So, chemical reaction in terms of symbol is chemical equation. Now, let us talk about how a chemical equation be more informative and how it can be balanced. So, let us talk about the difference between balanced and unbalanced chemical reaction. So, first thing is when the number of atoms on the reactant side and on the product side are equal, we call them as balanced chemical equation. And if we write any of the chemical equation, it would be complete, it would be correct only when we write its balanced form. Because we need to balance the equation in order to manage the law of conservation of mass. That means total mass of reactant should be equal to total mass of product. That is the law of conservation of mass and would be hold true only if the total mass of reactant would be equal to total mass of product, and that can be done only in a balanced chemical equation. Whereas unbalanced equation, we call it as skeletal equation. It has unequal number of atoms or substances present in the reactant and product side. So, whatever be the reaction would be given to you, you always are supposed to write in a balanced form. Then only it would be considered to be correct. So, we can say that an unbalanced equation has unequal masses also and thus the equation is not correct. So, we need to write in terms of proper masses and thus I am saying that we have to follow the law of conservation of mass. Now, we know that as the matter which can neither be created nor be destroyed. Similarly, when we talk about any chemical reaction, the atoms which are present on the left side, that means as reactant, changes into product, that should be same in number, that should be same in mass. Because the law says that matter can neither be created nor be destroyed. It means it should be in the same manner. It's only the rearrangement of the atom takes place during the reaction and this is also the reason for balancing of chemical equation. So, if I ask you why we are supposed to balance the equation, you can say that to satisfy the law of conservation of mass in any of the chemical reaction. We can never change the formula of an element or compound to balance the equation. We need to follow certain set of steps to balance the chemical equation. So, let us discuss how to balance the chemical equation. So, what is balancing? Balancing is that process in which we make the number of reactant and product equal, their masses equal. So, that we mean is balancing. So, we can balance just by counting the number of atoms on left side and right side. If they are equal, it is balanced. If they are not equal, we have to follow certain steps to make them equal. So, now how to make equation more informative? So, it can be more informative by writing their physical state along with the reactant and product. That means what is the state of zinc, what is the state of hydrogen, what is the state of copper sulfate. Need to write the state along with the reaction. By indicating the heat changes taking place in the reaction, we need to indicate what are the heat changes, whether the heat has been absorbed or evolved. and by indicating the conditions, if any, like what are the temperature conditions given to the reaction, or the pressure condition, or sometimes some catalyst has been added, we need to mention those, and by using these steps we can make any equation more informative. That means we can now get more information from the same equation by introducing all these points into a chemical reaction. So, how to indicate the physical state? We need to find in what substance, in what state that substance exists. Say zinc exists in solid state, we will write zinc as the symbol Zn and write in bracket as S, which stands for solid. Similarly, if any of the substance is in liquid state, we will write L in bracket. If any of the substance is in gaseous state, we will write G in bracket, and if any of the salt in solution state, we call it as aqueous, and we used to represent it by writing AQ in bracket. Similarly, to indicate heat changes, if the reaction is endothermic, means heat has been absorbed, we need to add heat towards the reactant side, and if it is exothermic, we need to add heat towards the product side. So, this way we can explain the endo and exothermic just by writing heat towards left side, which shows the endothermic reaction, or right side, which shows the exothermic reaction. So, by using the heat symbol also, we can make our reaction or equation more informative. For example, we know that respiration is an exothermic process and energy is released or produced during the process. Similarly, when we talk about burning of magnesium wire, which forms magnesium oxide, is also an exothermic process. So, we just write heat towards product side, which shows that the reaction is exothermic. The reaction in which heat is absorbed, we call them as endothermic, and as I told you, we will write heat along with the reactant side. For example, decomposition of calcium carbonate is endothermic process. Photosynthesis is also endothermic process. Even electrolysis of water is also endothermic process, where we pass electric current to break water molecules. So, all these are examples of endothermic reaction. Now, how to indicate the conditions? So, let us discuss an example. We are having potassium chlorate KClO3 on heating. So, this triangle is the symbol of heat. So, we can just place heat as in the form of symbol triangle. MnO2 is a catalyst which is placed below this arrow, and in bracket we can see these states. S stands for solid and G stands for gases. So, we have written the physical state along with that substance and the conditions of temperature and catalyst in this reaction, which shows that the reaction can be now made more informative, and we can say that the 2 moles of potassium chlorate, which is solid in state, on heating, because here I get the sign of heat, on heating in presence of manganese dioxide as a catalyst, will get 2 moles of potassium chloride, which is in solid state, along with 3 moles of oxygen, which is in gaseous state. So, just by using these simple steps, we can easily make our reaction or equation more informative. Similarly, we are having another example where carbon monoxide react with hydrogen under conditions of pressure 300 atmosphere and 300 degrees Celsius in presence of zinc oxide and chromium trioxide in the presence of catalyst to form methanol, which is in liquid state. So, here you can see the reaction is more informative by adding these conditions or symbols. Similarly, when we talk about photosynthesis, we can write the photosynthesis reaction in this manner and can make it more informative.